Hi guys, welcome to second semester Algebra 2. Let's go ahead and jump right in today with Chapter 5. This first video is going to be very heavy on vocabulary, so feel free to pause at any point in time so that you can write down the vocabulary words. We're going to start with this chart where we are going to classify our polynomials based on their degree. The degree is the highest exponent that you see in the math problem. For our first example, we are given a polynomial, or rather a monomial, that is the number 5. Now, the degree is based on the highest exponent on your variable, and since this problem does not have a variable, the degree would be 0. When the degree is 0, we call this a constant. For my next example, I have a polynomial, specifically a binomial, x plus 4. In this problem, my degree on my variable is the number 1. When the degree is 1, you call this a linear polynomial. For our next example, we have another monomial with one term. This time we have a degree of 2 because our exponent is the number 2. And this is called a quadratic. Quadratics are what we finished second semester with, all of those x squared parabolas. Here is a trinomial where the highest exponent is the number 3. When you have a number 3 for your highest exponent or your degree, we call that a cubic. If you've guessed, our next degree is going to be the number 4. So again, it's the highest exponent that you see. So it's the number 4. And this one is called a quartic, like a quarter, right? 4 quarters in a dollar. And then finally, we have the number 5, and that is called a quintic. Now, anything bigger than 5 does not have a special name. You would just say the number and then the word degree. So if 6 is your biggest exponent, you would say 6th degree, or 7 would be 7th degree, or something like that. So these are the vocab words, and then you just need to remember which one goes with which exponent. Now, I was using some other words as well when I was explaining how large the polynomial was. So let's go ahead and write those words down so that they are official. Now, these are the same examples that I had just given you, but this time we're going to focus not on the exponents, but how many terms it has. Terms are separated by adding and subtracting signs. In our first example, this only had one term. It was just the number 5. When something only has one term, we call it a monomial. In our second example, there were 2 terms because there was a plus sign. There's the letter x and the number 4. When something has 2 terms, we call it a binomial. In our next example, even though we have an x and a 4 again, since they're right next to each other and there's no adding or subtracting, they are considered to be one term. So again, a monomial. In our next example, we have 3 terms. We have the 4x to the third, the negative 2x squared, and the x. So again, separated by adding and subtracting, and this is called a trinomial. Next, we have another example of a binomial, 2x to the fourth plus 5x squared. And finally, we have something with 4 terms. Now, much like our degrees, at a certain point in time, we run out of special words and we just call everything the same thing. So anything that has 4 or more terms is just called a polynomial. Poly means many, so there are many terms. Let's practice a little bit of classifying things based on both their degree and the number of terms. First of all, when you're classifying a polynomial, it's important that you have it in standard form. Standard form is where you arrange it in descending order. So you want to make sure that you start with your largest exponent and then your next largest, next largest, next largest until you have your smallest exponent. So here we're going to write this in standard form, and then we're going to classify it based on the degrees and the number of terms. So 2 vocab words. Okay. In this problem, to write it in standard form, I just need to flip-flop the 3x and the 9x squared. So I want the squared first and the x second. The 5, which doesn't have a variable, always will go at the end. Now the degree of this is the number 2, which makes it a quadratic. And it has 1, 2, 3 terms, which makes it a trinomial. Quadratic trinomial. Now in Delta Math, they might ask you some more questions, so I want to go over a couple more vocabulary words with you. The leading term in this polynomial or more specifically a trinomial, is 9x squared. That just means the first thing when you write it in standard form. And the leading coefficient is the number 9. So coefficient is a number being multiplied in front of a variable. And then the constant is the number 5. The constant is the number without a letter. If there is no constant, then you can write the number 0. Let's try 2 more just to make sure we feel confident. In this problem, I do have also some combining like terms to do. So I want to put the x to the 4th first because that's my largest exponent. I do not have an x to the 3rd, that's fine. So the next thing I'm going to do is put the x squared. I do want to combine together the negative 6x squared and the positive 10x squared. Then I would follow that with the 4x, and I would finish it off with the negative 12. Since my largest exponent, my first exponent, is the number 4, this is a quartic, and it is a polynomial since it has 4 or more terms. Quartic polynomial. On Delta Math, it will also want to know that your leading term is x to the 4th. Your leading coefficient is 1. That's that invisible 1 in front of the x to the 4th. And your constant is the negative 12. Notice that I included the minus sign with the 12. Last one for good luck. In this one, I don't have any like terms, but I do need to flip-flop the negative 3x to the 5th and the 4x to the 3rd. Notice again, I kept the negative sign, the minus sign, in front of the 3x to the 5th. With a degree of 5, I'm going to call this a quintic binomial because it only has 2 terms. You do want to use the term word after you've combined like terms. So if you can combine like terms and make it smaller, you want to use your final answer to figure out what the polynomial, the number of terms is. All right, and then for Delta Math, don't forget our leading term is negative 3x to the 5th. My leading coefficient is just the negative 3 without the x to the 5th. And this one does not have a constant, so I would say that it is 0. There's not a number without a variable. This concludes our first video for today.